To start solving this exercise, the first thing will be to provide some information to have a basic idea of what will be seen around the video. First, Newton's law. Newton's laws are three principles responsible for analyzing and explaining the motion and forces of objects. The first law, known as the law of inertia, states that everything will remain exactly as it is unless another force is applied. The second is the fundamental law of dynamics. The net force applied to an object will be proportional to the acceleration. And finally, the third law, which is the principle of action and reaction. Every action will have a reaction of the same magnitude. There's three main terms that we need to know, that it's the motion, the force, and the acceleration. To apply Newton's law in a physical system, it is necessary to know the forces acting on the object. To perform a better analysis of these forces, a free body diagram will be used. This diagram is basically a representation of the forces acting on the object under study. Once we have the free body diagram, we will apply Newton's second law, the fundamental law of dynamics. This law consists of a vector equation which relates the vector sum of all the forces acting on the object to the object's acceleration vector. To apply this law, it's necessary to introduce a coordinate system in which the vector components, which are force and acceleration, will be worked on.
The steps that one must follow to apply Newton's laws of motion to a physical system are: first, identify all the forces acting on the system. These typically include A. The force due to gravity acting on your body, aka weight. B. The normal force exerted by the weighting scale on your body. C. The force of tension in the elevator cable if applicable. D. Any frictional forces if present. Now I'll show a little diagram to give a perspective of how this works.
In order to carry out the calculations, the formula force equals mass per acceleration will be used. Based on the formula, it will be clear according to the value needed. The moment the elevator goes up, the body will try to stay in the weight. Therefore, as Newton's first law states, the body exerts more pressure towards the floor. In the case that the mass is so, the formula force over accelerations equal mass will be used. When the elevator is going down, it starts with the original weight of 65 kilos. Then we press going down, and for a moment it decreases 3 kilos to 61 kilos. Then during the descent, it stabilizes and remains in 65. When the elevator is about to stop, for an instant the original weight is 3 kilos, only to decrease to 65 when the elevator fully stops. When going to an upper level in the elevator, the original weight starts normal at 65 kilos. Then, when the elevator starts to increase, the weight increases 3 kilos to 69 kilos. Then, during the way up and to the stop of the elevator, the original weight, 65 kilos, remains the same.
We use the formula of force over acceleration to get the mass. When we get the mass, we divide the result by the weight it gave when going up the elevator, and we subtract 9.81 from the result, and we do the same with the weight when going down the elevator, but we add 9.81 to the result of the division.
Integrating Newton's law into problem solving provides a systematic and a creative approach to addressing complex challenges. With Newton's legacy and his revolutionary understanding of the universe, we can apply his law to overcome obstacles with precision and promote different types of innovation. By analyzing the motion of an elevator with people inside, we can apply Newton's law through an experimental approach by creating a free body diagram that includes the gravitational force on the person, the normal force of the scale, and other forces such as friction or air resistance. We can determine the acceleration of the elevator according to the equations previously taught.